Okay, guys, this is lesson 9. We're going to call this day 3. So before we get into doing some problems, we ended yesterday. What we're going to do is we're going to talk about just the listing of reasons. The reason I'm choosing to go with not a statement first, because the statement's a little bit easier to say. You should be able to start to put all of our things together. You start to make things that, angle A is congruent to angle B. Line segment AC is congruent to line segment BC. All of those things, we can say, they're all very specific to a problem, but the reasons we say these types of things generally come from a group of reasons. We use sometimes the same reason 4 or 5 times because it's true that many times within the two triangles or the shapes where we're trying to show are congruent. So think of reasons. Well, let's just do it right away. What were the reasons, real quick, for the triangles to be congruent? What were those from like 2 days ago?
Similar angles.
Similar angles, but what were the actual postulates?
Like AAS.
Angle, side?
Yeah.
Side, angle, side?
HL.
Side, and HL. Those 4 would be reasons that triangles would be congruent. Okay. That's good. What else can we say are congruent? We can say angles are congruent. Thinking back to what we've done previous lessons up to now, what are some reasons that we were able to look at angles and say, hey, they are the same. They are congruent.
Tick marks.
Tick marks. So obviously, I think the number 1, maybe on all of these, is we could actually say that it was given. If something's given to us, you state it. You got to still state the given. That's what starts our little puzzles or proofs out. But so that I would think would kind of lead more towards the tick marks being on the graph already, or the charts. What about your zigzag pattern? I think I may have hinted at that this yesterday. If I have parallel lines, right, cut by a transversal, we worked with that. We said that zigzag pattern throughout the parallel lines in that transversal were all congruent, but they all had special names. I'll put it on here. Corresponding is one of them. There's going to be no particular order. Corresponding angles.
Side.
No, there's no such thing as side angle.
Side.
No. None of those. Don't think of angle side angles or those things. Those are for triangles.
Alternate exterior.
Alternate exterior. Exterior angles, which leads then to alternate interior angles. So we have corresponding. Corresponding would be something like this angle and that angle. Alternate exterior is this larger angle is the same as this outside larger angle. Alternate interior, this angle right here, is congruent to the other side angle there. That's alternate interior. Corresponding, alternate interior, alternate exterior. I think we got some more. Maybe possibly with these itself. What do we call these ones?
Perpendicular.
Yeah, they're congruent, but why? They're vertical angles. Vertical angles. Okay. So that's some stuff with our angles. We also could claim a couple things about angles. You have to have or know some definitions too. Like definition of a right angle, right? Definition of right angles means they are all 90 degrees and they're all equal, yes? We used a couple other definitions yesterday. What was another definition? Definition of perpendicular lines.
Reflexive property.
Good. We're getting there. Perpendicular lines. Definition of perpendicular lines says that two lines meet at 90 degrees or right angles. Reflexive property. Reflexive property said what? What do we mean by reflexive property?
It can go both ways. It's like a mirror of itself.
Mirror of itself, I guess, yes. That something is congruent to itself. So line segment CD is congruent to line segment CD to itself because reflexive property. Let's see some other things that we may have to do. What about cutting things in half? We dealt with some problems that had angle bisectors, right? So definition of bisector. What do you think that would actually be?
2 points of crossing.
2 points are crossing? More. Something cut in half. So if I take definition of an angle bisector, that means the angle is cut into two equal pieces. A definition of a line bisector or a segment bisector would be a line or a segment cut in half or two equal pieces. Very nice to know. Let's see, do we have anything else? What's the one where you already know the two triangles are congruent, so that means everything about them has to be congruent? It's the fun one. We learned it right at the end. CPCTC. That's a good reason to have some things. Let's see. From when I'm looking at the list of problems that we're going to be doing, guys, there's a whole bunch of reasons for things. And if you ever get stuck and you can't remember one of these words, or you can't remember or understand, maybe you know it's not this list, but it's something else. Maybe you don't know the shortcut, just write it out. Write out what you're trying to say. We can always then at that point say, oh, what you meant was CPCTC. That corresponding parts of congruent triangles are congruent. Because you're trying to tell me that, hey, if this object is congruent to this object, then these two pieces have to be the same because they're in the same corresponding parts. That is CPCTC. So, don't be afraid that just because it looks like there should be a one-word blank, if you can't come up with that one word on this worksheet, that means you can fill it in. Use your words. Back up everything you do with a reason why. So let's make a two-column proof for this, where we're given angle E is congruent to angle H. We also are given that EF is congruent to HG. Can we somehow figure out how we can show that line segment DF, which is in the middle, looks like, is congruent to line segment DG? Of course, it's a two-column proof, so you're going to write or make two columns. And the first statement is always, for me, and for us, it should be, all of the given. Angle E is congruent to angle H. and EF, line segment EF, is congruent to HG. Reason? Given. After I write the given down, I'm going to go to my diagram and you're going to write what you're given on there. Angle E. I'm already seeing that we're going to have to use a reason. Angle E and angle H are congruent. I'm going to put tick bands. Hey guys, we're also going to have to add another one to our list. There's more to this. Every problem you do, you're probably going to come up with something else you can add to your list. I would make or leave room in your list to keep adding. And EF is congruent to HG. EF and HG. Does everybody agree with this? They actually gave us two pieces. Two pieces are the same already. We are super close to at least stating one. It's not the final part of this problem, but we could get really close. How many more pieces do we need? We need 3 total, so we need one more piece to state that the two triangles are congruent. Which 2 triangles do you think they're talking about? The 2 outside ones. I think the DEF and the DHG triangles. The ones on the outside. So, someone give me a reason. Give me a statement, sorry, first. 2. What else would we like to say? What else would we like to say?
Angle, side.
Where, okay, angle, side. Where are you getting the other angle? I only have an angle and a side. You can't use it unless you state it first. So what angle do you want to state are the same?
Well, you can do E and H, and then F and G.
Why can you say angle F and angle G? Now, granted, hold on, guys. Are we allowed to just say angle F and angle G right now?
No.
Why?
No.
You can't.
Because there's like 2.
There's multiple angles. That's where we're going to have to use 3 letters now. But can I claim that this angle F, and I'm assuming that's what you're saying, Hunter, is the same as this inside of G? They look to be the same. Is that enough proof?
Well, yeah, because both sides are equal and both E and H are equal angles.
I don't know if that's enough to actually claim that. Not enough yet. Hey guys, this one's going to be an interesting one. How many triangles do you see up there?
4.
4. I think everybody sees the small left, medium middle, small right, and then the very large one that encompasses all of them. Are any of these triangles maybe special? Got a special name to it? Isosceles. I think I'm thinking one of these for sure is guaranteed. With the knowledge I have, we have an isosceles triangle. Which one?
Middle one.
The middle one. But guys, here's the problem. I'm going to disagree. It is, I think, a isosceles triangle. But without knowing any information about F, G, or D and their side lengths, is there any verification that this potentially is isosceles right now? No. So, but, wait a minute. Think about what isosceles triangles have. What do they have? That
2 sides equal.
2 sides equal and 2 angles are equal or congruent, but where are the angles relevant to the sides? You have to know these things. These are things that you should have talked about at some point, when you talked about, hey, that's an isosceles triangle. There's attributes to these shapes that you can use to your advantage. Guys, this very large triangle, I am going to say is an isosceles triangle. Because if two angles in a triangle are the same, the sides opposite them, which is ED, and from this angle, DH, are also the same. They open to the sides that are congruent. So therefore, I'm going to go up here and say, this side is congruent to that side. Or, DE line segment is congruent to DH. The reason, definition of a isosceles triangle. Maybe add that to our list. I'm pausing this. I'm not pausing. Definition of isosceles triangle. We'll try to keep this list going. Definition of isosceles triangle. Cool. Now, do we have enough information now?
Yeah.
Yes. What do we have enough information to state? Okay, the reason I heard side angle, side, but what's my statement? Triangle FED is congruent to triangle GHD. Remember to keep your order the same. What do we want to show again? What's the whole point of this proof?
To show that angle E equals angle H and...
No, actually it's not the angles at all. It's actually just the line segments. So, is DF now congruent to DG? I think we can now state that. And the reason is C, P, C, D, T, C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Okay, so your homework, does everybody have that written down? Your homework is going to be the worksheet. It's half already filled in as it scaffolds you through the problems. We're going to have a work day on Monday to continue to work on these. I want you guys to work in groups. I want you guys to struggle a little bit and come up with those reasons together. Most of our reasons should be part of our list. You guys are going to have to state, well, hey, look, they gave me a reason. What was the statement that goes along with it? That's interesting. Make sure we're using the correct notation. And that is it. We will do this one later. So, homework then. Day 3, worksheet. It's called 79. Number 79. So, have a great day.